Hey, what's up, guys? I did question 13 on our 6.1 online homework. So the question is, in using the bolt cutter shown, so this is the bolt cutter that's shown, a worker applies two forces to the handle right here, which this is the force being applied, as you can see. Determine the magnitude of the forces exerted by the cutter on the bolt when P equals 540. So that's P right there, correct? So what I'm gonna do is go ahead and write dimensions. In my question, I did struggle with all of this on my online homework as well. So I'm gonna just switch up everything. So I switched up already the pressure that's being applied, and I'm gonna switch up the dimensions and go from there. What I went ahead and did was put in the dimensions, and as you can see, I did millimeters, obviously, because millimeters is the best part to do for this, and also they're smaller. So I went 48 millimeters from the little ball to the little bolt. I went from the bolt to this bolt, 120 millimeters, and then from this bolt to the pressure being applied, I went 550 millimeters. And then from this bolt to this bolt, from that bolt to that bolt, it may not look right because obviously my drawing skills aren't the best, but it's both 72 millimeters right there. And then up here, we went from this bolt to that bolt, we went 36 millimeters. And obviously the P would be the pressure that's being applied to these cutters, which is 540. And now we can go ahead and do the free body diagram, and I'll go ahead and show you how to do that. We'll start with the FBD cutter for AB. And I'm gonna separate it from FBD cutter and then the FBD handle. So I'll start with FBD cutter first. So the cutter will look something like this. Then we can label the points. So point A would go right here, around right there. Point B can go around here. We can put B right there. And then now we can do the dimensions for this part. And let's do it. So we can go with B wide going towards the B. And BX going out. We just label that BY, BX. Then we have DA going down. And then we just have F going up. And then we just add both of our numbers, which I put 48 and 120. So we put 48 around right there, 48, and then the 120 from A to BY would be the 120 millimeters. And then we can move on to the FBD handle now. Now I can go ahead and label the points. We can start off with point B right there. We could put point C down here. And then we could leave that. And we know that we have the pressure coming from up here, so we'll go ahead and do that with the dimension in a bit. All right, so we know CY goes towards point C. So we go like that. We just label it CY. And then away is CX. So we just put that, and then we put CX. And then with B, same thing. We could just label it BY. And then away will be BX. Just put it over here. Just label it as BX. And then down over here, we knew that the P is getting applied, so we just put P right there. So from dot C and dot B, so from these 2 points, so we could just put around. So we could put like that. We know that it is 36 millimeters. And then from that dot all the way over there, just close it. we would do our 550 that we have minus the 36 millimeters, which would be 514 millimeters. And there you are with both your FBDs for the AB and the handle BC. So now we have our FBDs, the FBD cutter and the FBD handle, which is BC and then AB. And then this was our question. So now we can move on to the calculation. So we can start with the first FBD, FBDI. So FBDI right there. All right, let's go. So we could do sum of fx, which equals 0. And then we just find that our bx was going to equal to 0. So now we could do our FBD2. So right there. And then we could do sum of MC equals 0. So this is where we can use all of our numbers now, as you can see right here. So we can start off with putting 36 millimeters and then put our BY. So I'm gonna challenge myself on this problem right here, because in our homework we didn't find our BY, but right here I will find our BY now. So you guys can see how I go through with it. So I put 36 because we grab it from right here, this part, and then the next number would go right here. So this number is going to be from our FBD handle BC, which is our 514. So we put 514 millimeters, and then over here we just grab our newtons. So our newtons is the pressure that was applied with that right here. So we just put 540 newtons, and then we equal it to 0. So all of that equal to 0. And then our BY, so we got BY, which is going to equal, and let me go through the calculation real quick and come back to you guys. So when plugging it in, we get 7,710 right here. So our BY is 7,710. So that's something that we didn't have on our first problem. First question on 6.1 online homework question 13. We didn't have to find the BY, but I went and found it, which was a little bit challenging, but here's the final answer. So now I can find the magnitude of the force. So by finding the magnitude of the force, we go sum of MA equals 0, and then that. So the sum of the force, we will use the 120 that's right here. So we go 120 millimeters, then we close that, and then we still use our BY right here. So we would plug the BY that's up here. So the 7,710 would be plugged right here. And then we go minus, and then now we put in the 48 from right here. So put minus 48 millimeters. And we put the F, since we're finding the force exerted. So then equals 0. So I'll be back right now. So for the BY, as you can see, I will plug this in. So that's why I kind of had to find the BY, whereas in the first question I didn't have to, and I kind of just went through with it. But right here I have to plug in the BY. So let me go ahead and do that. So in the end, so our BY was 7,710 newtons, and then the magnitude of the force exerted by the cutter on the bolt is 19,275 kilonewtons. So these are our final answers, both of these, and this is a math that was being done. I kind of walked you through it, but till the end I had to use a calculator to figure it out. But yes, these are the answers, and there's the question once again. We used all that number, and this is our free body diagram right there. So to sum it all, I will go through it one more time since it's all done and everything. So I did add something to this problem, which was finding the BY of my cutter. So, well, not my cutter, the question 13 on homework 6.1, we had a cutter question, and I did add finding the BY as part of my question. So that's what I added to my problem and why I solved it. And so I did make different dimensions, different numbers right here. So I added different numbers. I made a different dimension. I made it way bigger than it was supposed to be. The free body diagram was cut into two. I showed you right here. So the cutter AB and then the handle BC. It was a bit complicated for the BC because the handle was way longer. I made it way longer than it was supposed to be, and it made it a bit tough trying to find the actual calculation of that. But I did what I could, and I did it. But I mean, it was all there, and in the end, that the handle BC, so the free body diagram, that actual 514 millimeters that I found on there, I had to use to find on our BY over here, which was helpful actually, but it was very tough trying to find it, and it made it very challenging for me to find it. But overall, I mean, I made the numbers way too big, but in the end we found the end product and we found our answers, and yeah, I mean, we were able to solve the problem, and there you go. Thank you for watching.